Hello, this is the first tutorial of the series Kindness is Powerful for Tome Churlinov. I started doing these tutorials saying thank you to all our supporters for donating to help Tome. First off, I personally want to thank our first donors, Mike Schrivers, I'm sorry if I spelled that wrong, and two anonymous guys. It means a lot to us guys. You give hope to our family and that means a lot, believe me. I will continue to be doing these tutorials in the future as thank you in return from me. In addition, if you want me to cover some specific topic, write me up in the comments either on YouTube or Reddit. My name is Kira, I am VFX Compositor. I've been in the industry for about 3 years now. First I started as prep artist and today at my day job I work as a compositor on films and TV shows. In this tutorial we will be studying the most common mistakes made by artists of all levels, either juniors or seniors or even supervisors sometimes. We will dive a little bit under the hood of a compositing software called Nuke and how it actually makes what we see on the screen and how it actually works under the hood. So from there we will learn what we should and what we shouldn't do. Also I will give some little useful tips and tricks that I found helpful in my craft. Basically this is a tutorial targeted at artists for levels and I hope you will learn something useful from it. Okay, so here we are in Nuke. First off I would like to start explaining the premult node, what it actually does in Nuke. For those who know, just bear with me. I will try to go as quickly as possible through this. So here we have a color wheel. I have set up a color wheel, a roto shape, and I draw a simple roto shape mask and a premult. So when you put a premult, it actually cuts the image based from that alpha coming upwards in the pipe, right? So what is it? What is this? This is actually a simple multiply operation. The premultiply node takes the alpha channel and as you see we have a 1 value here at this pixel, and if I move it here we have 0, right? So every number multiplied by 1 will return the same number as it was in the original image. Every number multiplied by 0, it will have to return the 0 value here in the RGB as well. So this is actually a multiply operation. And if we zoom here in the edges, if we take a look at the alpha, we see that we have a semi-transparent alpha, right? When I pick a value here, you can see that this is changing. Here we have a 1 full opaque, 0.7, 0.5, 0.2 and a complete 0. So for these values in between, and this is actually how the soft edges are made. This value has a value of 0.5 and on the corresponding image of that pixel value we have a number 1, right? So multiply that by 0.5, you get the result back here. So this is it. To prove you that, I have copied this on the other side. This is this very same roto shape mask, the very same color wheel, and instead I have just used merge with the multiply operation here, and we have exactly the same result. So take a look and I compare the two. We see the exactly same result. So remember, premult is only a multiply, where on the other hand, unpremult, it is the opposite, and that is divide. To explain the divide or unpromoted function, let's roll to another example here and see what we have. Here I just have a constant and I've put myself around, so I create a basic background and I have rendered out a basic shape pyramid, a basic model pyramid from Maya. It's a very lousy render, I know, but it will serve our purposes just fine. So A over B, and we have the result, right? This is the background, this is foreground, A over B, and that is. But I have put myself in node here that this is a premultiplied render path. So it comes out from Maya, it's already rendered out as premultiplied path. It can come unpremultiplied or not premultiplied at all. So let's take a look at this. We already learned what the premultiply means, because this by itself, it has an alpha channel in it. It basically says this is a color value, this is a 0, I don't have information here, right? So if we take now an unpremult node, let's just ignore this on the left side for now. If we take the unpremult, take a look at the edges and what it happens. You see the full color here that it was in the render. So the alpha is the same, but it unpremultiplies or it divides the image with the alpha, and you get the result here that we are looking at right now. So if we compare the two, this is the difference, right? If I premult it back again, we see the exactly same operation. I mean, exactly the same result as the original render, here and here. So to prove you that the unpremult is the same to you, what I have here on the left side is I just put a shuffle, to shuffle all the channels, to shuffle the alpha channel to all the other channels, to RG and B as well. And I have take a merge operation with the divide function, and I have divided the image values based by the alpha ordinate here on the B byte. So if we take a look at the result and compare it with the unpremult, it's basically the same, right? And if we multiply it back again, we see exactly the same result as here pre-multiplied after that. So what you need to remember is that every color operation, every grade, every color correct, anything that you grade the image in any way, anytime you put a color correct, anytime you perform any kind of color operation, you should do it on unpremulted image. And let me show you why is that. So here we have the already premultiplied beauty path merged over our background, and I will put a grade node in between. I will just lift it up. Let's say I just want to lift the blacks, right? But if you notice, it's not only happening on the image, but it's happening as well on the background, right? If I disable, you can notice the difference. Let me just crank it up a little bit more to the extreme so we can notice, right? This is what is happening. And this is because here in the image, this is already a pre-multiplied image. What Nuke sees, and what the grade node says here, take every value with the lift, every black value, and lift it up by that amount. So even those that are zero number here, those are lifted up. So this creates a problem. So to bypass that problem, we need to firstly unpromote the image. If I copy the same grade node and I put it here, I grade it on unpromoted image, right? And if I premult it back, now we see the difference happening only on the pyramid, only where the alpha is. So if we merge this over our background, we see that change is happening here only on our foreground element. So this is the correct way, and it's not the only reason. Whenever you grade something like that, even if you don't crank up the black levels of an image, if let's say you put a gamma up, this semi-transparent level, the semi-transparent edges are not graded the same because of the multiply operation that is happening, because already this is a multiplied image, these are different values, and the grade is doing a different math. So if we take this, I'll just replace it with the old one here and compare the results, we will see a very different result, right? So remember, anytime you have an image, make sure to unpremult it if it's already pre-multiplied, unpromoted, put any kind of color correct or grade node or any kind of color operation in between, premultiply it back and merge it over. This is the correct way to do it. Many times I have seen artists that forget actually to do this. Even myself, so I had a habit of a kind. I'm forgetting the unpromoted node. So now I have created myself a simple. What is this? I don't know. How did you? Let me just type it in. I named it UGP toolset. Yeah. I create the toolset for myself. Basically, it's a combination of three nodes: unpremult, grade, and premult. Whenever I want to grade something, I pipe it in, and I'm ready to go without forgetting this dreaded unpremult. So yeah, you can do it yourself. You can just take this. If you want to create a toolset, you can create. Click here on the wrench icon, click create, select the menu where you want it to be stored. I want to be in my root folder comp, and I would call it UGP because I already have it in there. Nuke will ask me, do I want to overwrite it? Yes. So yeah, that's it. Please don't ever forget to work on an unpromoted image when you're grading or performing any kind of color operation. I forgot to mention that one of the most common mistakes is premultiplying the image twice. That is fairly easy to be done. Let me just copy the image here and show what I mean by that. So if you take that and put a gray node, let's say grade, you premult and you merge it over. Now, because this is already premultiplied image, we grade it here, we do some kind of color operation, and we premultiply it again. This is a mistake. This is a fairly common mistake that will produce a dark edge around the beauty path. See, if I disable and enable it. So that's why I created myself that toolset. So you need to unpremult. So yeah, and another thing is that you need to watch out for is not to forget to premult it, because if you merge over and unpremulted, you will get white edges around the beauty path. Another thing I want you to remember is that any kind of transform, you want to put it under the premult, like this. And also any kind of filter, like the blur node or the defocus node. I forgot to mention as well as tracker, because the tracker is basically the same as the transform. The difference is that it only contains keyframes from the tracking data. So why is that? Why the transform with the filters? Let me just put a matrix node. Okay, 3x3 grid. They will not dive into how matrices work in Nuke, but I just want to show you that a transform is simply a filter like the blur node. And let's take a look at this now. If I just put a 1 in the upper left corner of the matrix, or let's do that, and take a look at it. So what does it happen? If I disable and enable, I see a transform inside, right? This is 1 pixel to the right and minus downwards. So if I take a transform, and if I put 1 to the x-axis and minus 1 to the y, and compare the two, we get the identical results, right? So what I want you to remember that any kind of comp you have, keep to this rule. unpremult, perform any kind of color operation, premulted, and any kind of filter or transform or tracker, anything like that, before you merge it over. Remember this and try not to deviate at any time, at any comp you're working on. Now let's talk a little bit about the merge operation over in Nuke. What we took for granted is that it's a simple A over B, but what is actually happening under the hood in Nuke is it dates back from the time when the industry didn't know about any kind of digital packaging, any kind of digital compositing package like Nuke or whatever. So they used film, and I believe it was Industrial Light and Magic that came up with the solution first, but I'm not sure. You can look it up on the internet, and the technique is called double exposure, I believe. So I have made a diagram here. Please forgive my poor MS Paint skills, but I think it will serve our purpose here very well. So what do we have here? We have a foreground and we have a background. We have a mate from the guy we want to composite over our background, and we have the same mate inverted down here. So imagine this as a as a frame of a film that was filmed on a camera, and this is separate film. It was shot in another place. So what they would do, they would create a mate for what they wanted composited over and expose it once. This would be the multiply. And this is what they would be left over with, the result. Actually, it's only what they wanted to be composited over is left on the piece of film. The same thing happened for the background. They would take the same mate they created, they would invert it and expose it against the background, and they would create a hole for that character or whatever object is they wanted to compose it over, and they would put it one over another. So if you imagine, if you put this on top of this, the image would be completed like this. This is actually what is happening in Nuke with the merge over operation. When the first companies made softwares like Nuke or Fusion, that's what they recreated, the same process that was used before. So what is happening inside Nuke? You take a foreground. This is what is happening in the merge over operation. So it's not outside. So it takes the foreground, the A pipe usually, it multiplies it by its alpha. It gets a result over there, and takes the background, it multiplies it with the alpha but inverted this time, and it gets this result. It pluses them together, and the result is a composite image that we see over here. To prove you this, I have a setup here that I want to prove to you that what I just explained actually is happening inside the merge operation. So I have a constant. I have created myself a mask, an alpha with rough shape node, and I have a checkerboard. So now I want this composited over this background. So merge over this constant with the checkerboard and this rough shape. Let me just turn off the RGB and put it on with working yellow. If you premult it, A over B, we get this result. So let's take a look again at this diagram. We have the foreground, we have the alpha, and it's multiplied against each other. So we have the foreground, this is what we want to compose it over. We multiply it by the alpha, with that mate. We're left with this result, right? If we take a look again, it's exactly the same. We took only the character we want to compose it over. On the other side, what is happening is we take the background, we multiply it by the inverted alpha, and this is it. This is the background. We multiply it with a merge multiply node against the inverted alpha this time, and we are left with a hole for the composite image that we want to put over. In the diagram, in the diagram here, we see that this is a plus operation, so these two results, we need to plus them now. If we plus them together, this is what we are getting. The merge over operation is actually the same. If we compare it here with this output here, it's exactly the same. I'm changing between these two and we see no apparent change in any. So this is what is happening in any merge over operation you're putting in your comp. Another example I want to show you is here in this site. I have downloaded two images from the internet, from Windows and a random bar from somewhere, and what I did is basically the same as here, what we just explained. So what we're doing, I took the image, and this is just connected to the image itself. I pulled the key, I just eroded here, I shuffled all the channels to be in the RGBA with the alpha, and I just multiply, just as here. So this is this operation, foreground multiplied by itself. So we are left only with the character right here. This is the result we had. Now we need to do the same, but with the background, but only with the inverted alpha. So we take the same alpha, the same mate, we invert it and multiply it against background, multiply it with the background. We are left with the hole on the background. So the next operation is plus these two together and you get the result hole. This is it. Here I have the same operation, but we just use the default merge over operation inside Nuke, and if we compare the two, they should be exactly the same. Now I'm changing between the two and there is no change at all. So this is your merge over operation in a nutshell. Now let's talk a little bit about concatenation in Nuke. Here we have a checkerboard, just a checkerboard, and three transforms. The first is doing translate on the x-axis by 100. The second is doing rotate by 100, and the third is doing a scale of 1.3. So this is what we're left of. So what is concatenation? Concatenation is actually Nuke looks for any mathematical operation that can be collapsed in one single mathematical operation. So think of it like this example. If we take +1 plus -1, they negate themselves. The answer, the equation is 0 at the end, right? So this is what is happening when I say concatenate. So Nuke is looking up the stream if it can find any mathematical function that can be collapsed into one single mathematical operation. So here we have these transforms, and down here I have put the very same transforms but in the reverse order. So here we have the transform x first, rotate, then scale. So now we put the scale first, the rotate then, and the transform last. So this is the scale, this is the rotate, and this is the transform. But note we have checked the invert. What this means that it inverted the matrix inside. If you remember, the transform is only a filter, which we'll not talk about in depth about this in this tutorial. So it actually takes this value and says do it but in an inverse. So it's a reverse of 1.3 scale in this example. So when Nuke recognizes that something can be collapsed into one single mathematical operation, it negates that operation. So it's basically the same as it does not do it at all. So what I mean by that, because if we take a difference node, plug the A to the left transform here and the B to the original, and look to the alpha. Let me just crank up the gain so we can see better. We see in the alpha channel, we are right now in the alpha channel, we have 0 value. That means we have no change at all. If I put a transform in between, and let's say just scale it a bit, we immediately see that there is a change in the alpha channel, and this is the difference between this output and the original one. So I'll just delete this one. So what I want you to be aware of, that this kind of operations can be broken inside Nuke. So an example, if I only put a grade node inside between these two, I immediately break that concatenation. So we're looking through the difference node in the alpha channel, and the grade is doing nothing. Everything is at its default value. If we see here disable, enable, we see no change at all, but this breaks the concatenation process in Nuke. So be aware of this one. So it's not only the grade, it's also the blur, it's also the defocus, and etc. So now, since we're familiar with the concatenation in Nuke and what is happening and what can break it, also forgot to mention that color correct node can break the concatenation as well. Let me show you another example. Collapsing these mathematical operations can happen not only with the transforms, but also with the color operations, with the grade especially, with the grade node. So here I have another example. We have this pyramid. I have my first grade node, gain at 2.9, and the next thing I have grade. This is basically the same grade, but I just take the reverse, which is the same as the inverse checkbox of the transform, right? So if we compare this with the original, it's basically the same. If I put a difference here, compare the output with the original image, let me just crank up the gain, and we have 0 value, right? I mean that here, because this is where the image is. So what is happening is basically the same. Nuke is smart enough with the grade nodes, it can recognize this pattern upstream from here to up to the where it's connected, and it can say, okay, this can be collapsed into one single operation, and I only need to do it once, not twice. So because this is the same and this is the reverse, we are left with no change at all in the image. Now I want to introduce to you a very common mistake when someone wants to perform 2 or more color operations with one single mate. So if we take the mask channel from the first grade and connect it to the rod shape and see the result, we will see a very expected result, right? This is exactly what we want. The mask works only where the alpha is in the rod shape. But now if we take the mask input of the second grade and plug that to the rod shape, and when we take a look at our result, we're introduced with a very horrible edge problem. Now, if you will say, I'll take this by blue. Now, if you say I'll fix this by blurring the alpha, it will make the problem even worse. So let me just put a blur here and show what I mean by that. You see, the edge problem is becoming even worse now. So why is this happening? Because whenever you plug the mask channel of a color operation inside that node, in our case the grade node, is happening exactly this. It's what we covered earlier, the over operation. Yes, that's exactly what is happening every time when you connect the mask input of a grade node inside Nuke. So this tells us that this operation breaks the concatenation by itself between the two grades. But also, I have recreated the same result here on the left side with the same grade nodes, but this time instead of using the masked channel, I used the same process as explained earlier when I was talking about the merge over operation. Do you recognize the pattern here? So, the grade node here on the left side is identical with this one. If we compare the results, we see that they're exactly the same. This output we see here is actually our foreground image. This is what we want composited over, right? This is what we want to happen to grade it over our image here. So let's use the same method as we explained earlier in this diagram. So I take our over image, we multiply it by its alpha, and now we take the background image, we multiply it by its inverted alpha, we're left with these two results, right? And the next thing to do, if you remember, is we need to plot them together. And voila, now we have the exact same result as here. Let me just replug this in. And if we compare them, they're identical. So let's do the same now for our second grade node here. So we take the background, because this is where we left off. Now this is our background, this is where we left off, this is our result, and we continue from here. We take this input, we want to grade now with our second. Let me just copy it over to make sure that it's the very same grade node. We perform the color operation. We again multiply that by the alpha where we want to composite our over image, or in our case the grade where we want to happen. And now we take the background again where we left off, we multiply it by the inverted alpha, and the next thing to do is plus these two together, right? And now our final result is this. So when we compare it with the grades where their mask channels are piped to the road shape, we see that they are exactly the same. I'm now changing between these two outputs, and we see that the result is the same. The correct way to do this kind of color operations is with the use of the Keymix node. So let me put in a Keymix node here. Just take these two grades and copy them on this side, replug it, and now I will copy the A input of the Keymix to my last grade and the B input to the ungraded image, and I will connect my mask to the rod shape. And now when I see the problem is gone, there is no edge now. The image is identical to the original image, because here we do the grading operation, and here we do the reverse of the same grade above, right? So this is what we would expect to see. And using the Keymix, we remove that horrible edge problem that we had earlier when we used the grade nodes that use the mask channels piped into the rod shape. So whenever you're grading images with two or more color operations, and you need these to be plugged into a single mate, then you need to use the Keymix. That is the correct way to do it. Don't try to blur the alpha, that will only worsen the problem up. Down here I have exactly the same thing recreated with our image from the bar earlier. So on this side I have this image, I have reformatted it only. Now I have the grade, I have an alpha, I grade it up with this grade, and I have exposure, which I use it in the color to change the color inside this. So on the left side here, we have recreated the same thing, but only this time using the Keymix node. You see the mask channel of the Keymix is plugged into the same mate, right? This is what it uses, and also this is what on the right side these two grid node and the exposure node uses. So you would expect the same result, but that's not what actually is happening. This is the correct way of doing it, and if you compare the two, you will, I don't know if you can notice the difference here, but it is happening. So whenever you use this, you don't get the expected result, the expected mathematical result when you use this method. So again, every time you use a color operation that you need to plug these two into the same mate, you need to use the Keymix. This is the proper way to do it. Another thing I want to show to you is that many of the nodes, like here we have in, out, stencil, the mask are basically the same. It's only the order and the math is done, it's different. So what I'm talking about, let's say for example on in out are generally used to combine mates or cut out something with the alpha. So perhaps you recognize this, right? This is basically the same, very exactly the same as the multiply what we used. It's actually the in, I believe it was the in. So let me just put a multiply node in here. Not like that, but a merge operation multiply. Connect that to the image and the B to the road shape and see the result. Oh, use this to put all the channels into the RGBA of the alpha. So if I compare the multiply and then see the in operation, this is exactly the same thing, right? So even if you take a look at this, if you hover your mouse over it, you will see this list, and it mathematically describes what is doing each operation. So if we find the in, if you take a look at the in, it says A, capital A with small b. So it basically takes the A input, it takes the image and multiplies it by that alpha plugged into the B channel. If you compare it with the multiply, ignore that A if A less than 0, so this excludes are okay. So take a look, multiply A with B. This is exactly what is happening. So you see, on the other hand we have the out. The out is the reverse within what it takes. If you take a look at the description, let me find it out. It says A 1 minus B. So what it actually does, it takes the inverse of the alpha channel, the B input channel, and multiplies it that. So this is actually inverse of our alpha. It inverts that alpha and multiplies it by that values. So again, we can say that this is exactly the same as the multiply, only it inverts the alpha inside. This stencil is the same story. Only this time, if you compare the out and the out and the stencil, they're basically the same. Only the inputs they take are different. So in the out we have the A input plugged into the image, and in the stencil we have the B plugged into the image instead to the road shape. So this is exactly the same operation happening. Also with the mask, again A with B, and here in the in operation we have A with B. So all these nodes we use, all this operation we use when combining alpha or cutting out an image with them is actually a simple multiply node. I want to show you a problem now that incorporates the use of the stencil and the mask when recombining an image with it. So here we have the beauty path, we have the pyramid, We have a rotor shape, the very basic rotor shape that we used earlier, and I stencil this image over here and I mask it on the other side. So I get these two. So, for example, I wanted to do some kind of color correction here. I could just gain it up a bit, and I wanted to merge them all, right? And you would think this is the right way to do it, but it's not, because if we merge this over now again over the image, over a background, excuse me, again this checkerboard, if I zoom in, here we have a seam. I don't know if we can see it, but if I put a gray note on the background, on the checkerboard, and I'm grading the checkerboard now, as you can see, we have a seam, we have a hole inside. And why is that? Because it's actually the same thing is happening as the overall operation when we explained what is going on. So here we have the multiply, we have another multiply, these edges are lowered, these semi-transparent pixels are lowered by the value of the alpha here, which are lower than 0. I mean, excuse me, they're lower than 1, but higher than 0. So when we over, we have this seam in the alpha. This is what causes our problem. So multiply and multiply, the next thing when we're combining to do is, as we see here in the diagram, is a plus, right? So if this over, if we actually change this over to a plus operation, the problem is now gone. I want to show you another method of cutting an image with a mask. So let's just copy the VFX on the checkerboard down here, like that. I will put a rotor shape node and we'll draw a mask, so just a quick mask over here. And now I want to cut this image, to use the inside of the image and merge it over the background. So what I can do instead of using the inner, the stencil, and the out and the mask now operations, merge operations, I can use a grade node instead. But how would I do this? I will connect the grade node, and this is important. I will change the channels to alpha. I would offset the channel. I would offset the alpha channel to -1. And if I take a look, now we don't have an alpha channel, but now I will connect the mask input into the rotor shape. Now I get this, right? This hole inside, but I need this to be opaque. This inside, I need it to be opaque. So because of that, I will just click the invert, and this will inverse the mask. So if I now premultiply this and merge it over, we have our image composited only where we want it with the mask. One thing to be aware of using this method is, if you already have an image like this one, let's say it's a CG render and it is already pre-multiplied. So if I wanted, let's say, to cut out this portion of the image here, I can just put that mask over here. I would create a problem with double premultiplication, because now if we see at the alpha, with the premult, we're saying multiply all these values, all these RGB values, with the alpha upstream that is coming from above. So if I take it and premultiply it, we now here on these edges we have a double premultiplication, because if I compare these two, you can see that this method now created the problem where the image is darker, right? This is because this image is already premultiplied. This alpha says premultiplied again with this premult. So the way to fix this is actually to put an unpremult node over here. So now the image is premultiplied. You cut the alpha and you premult, and the problem is now gone. Even without the unpremult on this side, the image would not have a double premultiplication problem. And why? It's because at this point of the image, at this portion of the image is not premultiplied. It only happens on the edges. So at this point of the alpha, on this edge actually, we are doing the first premultiplication here. So yeah, you can use this method. I use it very often. I prefer it, and I believe this is by text. I learned this from my supervisor at work, but I like it pretty much, and it's kind of fast. I can work fast with it. I can just put a grade node and grade it off, offset, invert the alpha, whatever I want, with only single grade node. So what I forgot to tell you is that you need to watch about this white clamp. Whenever you're working with an alpha, you need to work between the range of 0 to 1. So if you forget to click this white clamp or the black clamp, you can get higher numbers than 1 or lower numbers than 0. So that will create a problem in your comp. So remember this, whenever you're using the grade node to cut alpha, to do anything in the alpha, remember that you need to clamp these values. Now I want to show you how to combine your mates, how to combine alpha. So let's go over here. Here I've created roto shape and another roto shape node, and I combine them with over. Basically, remember this, you will need only an over operation to combine mates and nothing else. So let's see why is that. In these next examples I have, these are the same roto shapes, but I use a different operation. Here in this example I use a max. So I know where you will need to use this. Why? Because the max operation, it takes the highest value of an image, of, let's say, it compares the two. If at this point the value in this image is higher, it will take this pixel instead of this one. So it kind of creates a match between these two. Now let's compare the plus. The plus compared with the over creates different result, and if you this is actually a little dangerous. Watch out if you want to use a plus. So if you take a look at the values here, we can see that some of the values go higher than 1, and as we said earlier, we need to use values between 0 and 1 whenever we work with alpha. So to fix this problem, you can put in a clamp node where you would clamp those values and go between the 0 and 1 range. So the next operation we have is screen, and if we compare the screen with the over, they're identical. The very same operation what is happening when combining an alpha. So there is no point why to use a screen operation. Also, as well as the mate. The mate operation does the very same thing as the over. So remember that whenever you want to combine mates, you can simply use the over operation. Now I want to show you how to combine mates with the Keymix node. So down here I have a setup, and this is again window, and what I did here, I pulled, so in this side I have made myself a mate for the alpha. I use this medium just to blur out the irregularities of the image, like compressions and stuff, because this was downloaded from the internet. So we'll get a little bit nicer key out of this, and I blur the alpha to soften up the edges here. And then combining the Keymix combining the alphas, these two alphas, based on this mask. So this is my initial alpha, and I see that the alpha is broken here, it's not working very good with this edge under his arm. So this is why I created this second alpha, the second mate, and I want to put this alpha inside it, actually combine them. So I want this keyer 5 here to work only where the mask is. So I use the Keymix and only mask the area where I want to work that second keyer. The next thing I repeat the process again. I use another Keymix, but this time I pulled the third key for this arm over here, for this hole between his arm and the body, and I mask the region with this road shape. So I'm basically telling this input of the Keymix I want only to occur where this mask is. So again, this works only where the mask is. So this is how we use the Keymix, and you can put how many you like this, and this is very common use when you're compositing, when you're using a lot of keyers to pull out a good key for any kind of shot. Now I want to talk to you about CG compositing a little bit. So if you scroll down over here, I have made a setup that we use the same beauty pass, we use the same background again, but now we have introduced a reflection pass. So let's say we wanted to grade only these areas, only these highlights, only this, actually to be more precise, the reflection of the image. To do that, I would naturally need to have the reflection pass. So I did this, I render out this reflection out of my head. So how do we use it? First off, let me show you here on the side a little simpler. If I use A with B and minus that, let me just switch this, and now let's compare the result. This is the original image, and this is the minus, after the minus operation. So what it's actually doing is takes this reflection path, it's subtracted from the original image, and now it's like there was no reflection on this render. Now this allows the render, you wouldn't see this exceptional notice, but if we had a pretty good render, you could remove any kind of path from your beauty path, like if you had shadows, if you had I don't know, occlusion or anything like that, you can use this to minus it. So why do we want to minus it? So because now, since we minus this, we can separately grade this path. Let's say I wanted to change the color to reddish, something like that. And since now this is minused, because as I said, now it doesn't contain the reflection path at all, I can reintroduce it back with a plus, but now this time it's graded. So you see the difference here and here. We have only affected the reflection path and nothing else. This is, I believe, called subtractive method of compositing, and it's called subtractive because we are subtracting the reflection path in our case from the image. We are showing it again later with plus over. But in between, it's completely safe to do whatever you want, whatever color operation you want. So if I wanted to make it a little bit more into the extremes, I would crank it up with 20, and now the change is very apparent, right? So if I disable and enable, You see the difference that it's only happening where the reflection is of that beauty path. So now I want you to take a look at this side. Ignore this unpremult and premult for now. But notice that here I use a from instead of a minus. So for simplicity, I would just say that the from works the very same as the minus, but only I prefer to use from instead of minus because it doesn't break the the natural way of nesting my merges downstream. So here, as you see on this side, I have A, B, and then B, A. So it kind of looks strange to me. It's unnatural to my workflow in my comps. So that is why I use the from. This is exactly the same operation. I mean, for our purposes, it's exactly the same operation. It only takes different input. So the reflection minus the master beauty, and now we can grade it and plus it over again. If I take the same grade over here and I replace it, I'm sorry, and compare this result with this, it's exactly the same. So it doesn't make a visual difference at all. It's only a preferable method of working. Another thing I want you to remember is that, as we said earlier, any color operation you're doing to an image, you need to do it before it has been premultiplied. So that's why I am premulted. This is one color operation, then I close it back again with another premultiply here, and we merge it over. So this is how subtractive method of multipass compositing works. And the last thing I want to talk about in this tutorial is about method of mine that I want to use, cheap trick actually, that I want to use when I want to pull data where there is no data for tracking. So let's say we have an image here. I have downloaded this image from the internet, the Statue of Liberty, and let's say we don't have enough information here for tracking. Let's pretend that we don't have these dots or these features here or anything like that. Actually, let me put a blur node here and blur this image a bit, like that. And now we only had this area to pull a track from. So what I would do first, I would create myself an luminance map, and to create a luminance map you only need a saturation key. You lower the value to 0, so the saturation is 0 in the image, and you change the luminance map to maximum. Now this is our luminance map, and what I do, I branch this off. I have a blur node that works on all channels, and I would put it to a number, let's say 10, and now I have a minus here. So I subtract the saturation, the luminance map from the luminance blurred map, and I'm left over with this result. So you can see that it is produced fairly good information data that is easily trackable, a tracker node inside Nuke. Now for this example I only have an image, I don't have a sequence to show you that this is working, but I tell you this is working. The only thing you need to do first is to remove the grain, remove the noise, denoise the plate. Another thing to do, to reintroduce some of the loss values, because if you take a look here, now we have negative values. I divide the result over here with the luminance map again. Now I'm introducing even, if we compare it, I'm introducing even more details back to the image. The next thing you can do is grade it, make it more contrasty or so, and this is trackable. This is already easily trackable for a tracker. You can always use, let's just say here, a grade node, and make the shot more contrasty, which from time to time will work. and this is actually what you need to do when you want to pull a good track. But in some extreme cases, I find this very useful. Remember, you make a Luma map with your saturation node, you put it to 0, change it to maximum, branch off a blur, branch off minus, subtract that Luma map with the blurred Luma map, and you get this result. To get even more results now, you divide this result with the original Luma map, and you can play with it. You can play an example. Let's say if I put a blur here, I can play with these details, and this also can serve as an edge detect if you want to use this as a make. Let's say if you want to grade some of these edges down for any non-apparent reason, I don't know why. So where this is not working, we need to put this into the alpha with the shuffle. So you see now we can create only these edges that we kind of faked our own edge detect here. So yeah, I think this is it. Thank you for your time, thank you for listening, and I hope you learned something useful from this tutorial. And again, I want to say thanks to all our donors, because these tutorials are made as a way to say thank you to all who donated for my father-in-law, and we'll be doing these tutorials in the near future. And if you would like me to cover some specific topics, please write me below in the comments or on the Reddit post. So yeah, that's it. Goodbye, and thanks again for helping out. Kindness is powerful.